All right, I'm doing notes on GCF for Algebra 2. GCF stands for greatest common factor. This is something that would be a lot easier if you knew your times tables. It just kind of pops out immediately. Basically what it means is, can you find between a term, in this case a term can be a number, it can be variables, it can be both. Can you find the greatest number that divides into it? So for instance, 12 and 24, the answer is 12. And how do I know that? Because 12 goes into 12 one times and 12 goes into 24 two times. The other factors include 1 and 2. I'll list them all out basically. You get 1, 2, 3, 4, not 5, but yes to 6, 7, 8, 9, 10, 11, 12. So basically, 1 goes into these easily, obviously. 2 goes into both. 3 goes into both. 4 goes into both. 6 goes into both. And 12 goes into both, with 12 being the biggest number. I'm going to do number 2 quickly. There's a 1 in front of this x squared, and there's a 4 right here, so there's no common numbers. I don't have to worry about the numbers, but there is an x common in both. So when I factor this out, it's going to look like this. And how did I get that? Because I literally said, hey, I see an x that can go into both of these problems. So I write it by dividing the x out. Remember, when we have parentheses like this means distribution, which is multiplication. So that's how you do that one. Number 3, and again, I'm going through this very quickly, so y'all can watch this video over and over. Number 3, I can see in my numbers that 5 goes into both numbers, and there's an x that can go into both of those as well, too. So I can factor it just like this. One second. So I can factor it just like this. Sorry, I had to push pause real quick. So it looks like this. 5x goes into both of those. And what's left, when you do 5x squared divided by 5x, you're left with a single x. And then 5x goes into 5x one time. Going to the next one, negative 3x squared plus 7x. The numbers, there's no common number that goes with each other, so I can leave the numbers alone. But there's an x that can go into either. So it looks like this. And again, I'm going through this quickly so that y'all can have a bunch of examples to look at if it still doesn't make any sense to you. And there you go. Once I divide the x out, I have that remaining over. I'm going to move to the next ones real quick. This one's fun on number 5. I'm not going to spend all this time talking about how I know the answer. I know my times tables. The biggest number that can go into both of these is 7. And since not all of them have an a, that's all we can do is 7. So I write my 7 out. 14 divided by 7 is 2. I'm going to leave my a squareds right there. 28 divided by 7 is 4. So I'm going to have a 4a right here. And then 21 divided by 7 is 3. And there we have it. Moving on to number 6, I can tell that 2 is going to be the common number that goes into all 3 of these. And then that's it. So I have 3x squared. And then plus 2x. And if you were wondering if you're doing this right, essentially, the answer is yes. You can check it. You don't have to, but you can check it by basically distributing. So when you distribute, let's see, 2x. If you were to distribute this 2x, this 2 into there, you would have your original answer. So 2 times 3x squared is 6x squared. 2 times 2x is 4x. 2 times negative 12 is negative 24. Going on to this next one, 15, 18, and 9, I can tell that 3 is going to be the biggest number, and then m squared is the one that goes into it biggest. So check it out. You can kind of approach these as separate little things. 3 goes into the 15 5 times. It goes, m squared goes into m4, m squared times, minus 18 divided by 3 is 6. M cubed, taking out the m squared, just leaves you with 1. And then plus 9, 3 goes into that 3 times. And then the m squared goes into it 1 time, which we just basically leave like that. So that's how we factored that. I'm going to do the next ones. Theoretically. Oh, is that all the ones we have on here? I thought we had more. Oh yeah, that is all we have. Okay, cool. Then yeah, that's how we do this stuff. If you're confused on this, I can walk around the room and help you with it. But this is basically straight up middle school math. And I'm not saying that to freak you out. I'm saying that to remind you that this is something you technically know if you have your multiplication skills down.